Alright, so we're going to look at chapters 2 and 3 of our pre-calc book, which is really a focus on our kind of general trig with the graphs and solving equations using our trig values. So if we're given a general equation like the first example, we want to identify a couple of things. We want to look at the vertical displacement, the amplitude, the horizontal displacement, and then what happens to our period. So the -3 is our vertical displacement. The amplitude is going to be 3. And then I look at my phase shift of 70 degrees, and that's going to be to the left. We'll be at -70, will be what happens to 0. So if I think about the point 0, if I want to put in a argument of 0 degrees into sine, that means that theta has to be -70. So I want to sketch my graph. I need to identify the period. There's no value that's multiplying my argument, so my period is going to stay at 360 degrees. So I want to sketch my graph. I go back to -70, and then I want to identify what happens to my sinusoidal axis. So it goes down 3, and then it's going to go up 3. And I ran out of room on my graph, but I have another bound at -6, so down 3 from my sinusoidal axis. So I start plotting points. I know that I'm going to look at quarter periods, quarter cycles, which are 1/4 of the period, in this case 90 degrees, because my period is 360. And I know it starts for a sine curve on my sinusoidal axis, and then after a quarter period it goes up to my maximum value, and then another quarter period goes back down to the sinusoidal axis. So that is half of a period. It would go down from there and back up to the sinusoidal axis at 290 degrees, or 70 to the left of 360 degrees. So that's what my graph looks like as a sketch. If I look at the next one, and that's half a cycle, I have a vertical shift of 1. It goes up 1, and then I don't really have an amplitude. I have a vertical stretch. I would have a negative value in front of the tangent, which is going to invert everything, make all my positive values negative, all my negatives positive, when compared to the parent graph of tangent. What's really tricky about this is the 1/4 part. That's what we call B in our equation. What it's going to do is that's going to affect the period. The period is equal to 180 over this B value, and the 180 degrees comes because the full period of tangent to begin with is 180 degrees. So I plug in my B value, and I get 720 degrees as my period. So I look at my sinusoidal axis. It goes up to 1, and then what I want to do is figure out where I have asymptotes and where I'm on that sinusoidal axis. So if I look at where sine of 1/4 theta is 0 and cosine of 1/4 theta is 0, I solve both of those. I know that the cosine values are my asymptotes because I'm dividing by cosine, and the sine values are on the sinusoidal axis. So I know that cosine of something gives me 0. The something has to be 90. So I set 1/4 theta equal to 90 plus 180 degrees times n. That's going to give me all the values of cosine that are 0. I multiply everything by 4, and I get 360 degrees plus 720 degrees times n. So there's my period. Do the same type of thing for sine, and I get 720 degrees times n. So again, the 720 deals with the period, and then the asymptotes deal with looking at the 360 degrees starting and then going a period from there. So if I start with n equals 0, that gives me an asymptote at 360 degrees and gives me a point of 0, 1. I would plot some points. I plug in values, and I can get the general shape of what's happening here, and I connect my curve. And then I don't have it on my graph just the way the axes are set up, but it would be symmetric. It would be flipped over that line y equals x to get me the values that it looks like on to go to -360. So the first two asymptotes would be from -360 to 360. And that, what I have shown, is really half a period. I want a full period, which would be 720 degrees. All right. We're going to skip the secant one. If you can graph cosine, you can graph secant. You just use the cosine curve in the values where you have a 0 for cosine. You're going to have asymptotes, and where you have a maximum or a minimum cosine value, you have the maximum minimum of those curves, those u values that you look at. So you can go back through and do that one. I want to talk about the domain and range for our values as we look at this. So sine and cosine, the only things I'm worried about in terms of domain and range, domain are the values I plug in, range are the values I get out. So plugging in values, I have no restriction. So my domain is all real numbers. The range, though, is bounded between -1 and 1. Those are the biggest values that I can get out on my unit circle. Cosine is the same thing. The domain is, I can plug in anything I want. My range is restricted to -1 to 1. Cosecant and secant. Cosecant is 1 over sine. So I'm going to have a problem where I have division by 0, so sine of something being 0. That's going to work out to be any multiple of pi. So sine of 0 is 0. Sine of 180 degrees is 0 as well. So any multiple of pi is going to be a problem. So that's not in my domain. And that's our set notation, which would be the set of theta such that, that vertical line means such that theta is not equal to a multiple of pi. This is because of our division by 0, which is an undefined value. Those are our asymptotes. The range are greater than 1 or less than or equal to -1. If I think about the u values that I have on those curves, that's what this is going to look like. All right, similar for secant, where I have not equal to pi over 2 or 90 degrees times n, because I can't have a multiple, I can't have a cosine value of 0, and that happens at my values of pi over 2. The range, same idea, bigger than or less than 1. Tangent and cotangent are related. Tangent has the same domain. You can't plug those values in. Those are going to be our asymptotes. However, the range is infinite. It goes up and down as big as I want it to be. Cotangent, same range, same domain. The range is going to be infinite as well, because my restrictions are on sine and cosine. So I have the same domain restrictions for cotangent and tangent that I have on cosecant and secant. If I'm converting radians and degrees, I want to look at multiplying by a value of 1. So I look at a unit circle value that I know to be the same. And the standard one that we use is pi and 180 degrees. So I have degrees on the top and the bottom, they cancel. I'm left with 285 pi over 180 radians. To look at radians to degrees, it's similar, but instead of having radians on the top, I'm going to have it on the bottom. So I have 180 degrees is equivalent to pi radians. I cancel my radians. I'm left with 540 over pi degrees. All right. These are a little tricky. We have standard definitions for arc sine. We also have arc cosine and arc tangent that we want to be familiar with. But arc sine, if I was to apply its definition, is sine inverse of -√2 over 2 plus 2 pi n, or pi minus sine inverse -√2 over 2 plus 2 pi n. That's my definition for arc sine. It gives me all the values that give me that ratio. And so I have to evaluate sine inverse of -√2 over 2. Well, that's a unit circle value, which means I have to be familiar with it. And I have to be familiar with the restriction on the range of our inverse values. So sine inverse only gives me values between -pi over 2, or 90 degrees, and 90 degrees, or pi over 2. That's the only thing I can get out. We restrict that range so that we get a function. If we didn't do that, we would have multiple things that could come out. We wouldn't be a function. We also call this the principal branch. So if we were to look at that point, it's down there, so I'm going to have a negative angle, and that's going to happen at -pi over 4. So I take out that value of sine inverse -√2 over 2 from my equation, and I plug in -pi over 4 to both of them. From there, I just need to be careful with my, my fraction addition. I want to look at the general solutions. I just combine what I can. And if I want actual solutions, I need to plug in values for n, so those are integers, the negative and the positive whole numbers, that give me things between 0 and 2 pi. So if I plug those in, I get, when n is 0, I get 5 pi over 4, that works. When n is 1, I get 7 pi over 4. Those are the only two that are going to give me solutions on that interval. And those are things that we really could have just looked at our unit circle and kind of gone from there. So it's a little bit more complicated when we have more of an argument, more of an expression to deal with. So don't worry about the argument, the thing in the brackets just yet. Solve it as we would normally until we have to take an arc sine. So we add 2 to both sides. I divide by 4, and I get to this point where -1/2 is sine of something. To undo the sine, we take an arc sine. So I have arc sine of -1/2, and I apply my definition of arc sine. So there it is. My definition of arc sine expanded. And now I have to evaluate sine inverse of -1/2. Sine inverse of -1/2, again, is a unit circle value. It's a negative value, so I'm going to have a negative angle because of my range restriction above. And that's going to be a -pi over 6. So I take out the sine inverse of -1/2. I put in negative pi over 6 to both of these equations. And now I combine what I have. And now I have to deal with the brackets. So I put back in that expression of pi over 8 times quantity x plus 2 instead of the brackets. So it looks like this. And now I have something that might look like a mess, but it's really pretty simple. It's just a linear equation with x. We're going to solve for x. I'm going to leave you to do that, where you would divide both sides by pi over 8 or multiply the reciprocal, 8 over pi, and then subtract 2. That would give you your general solution. And then if you wanted actual values, you would plug in values of n to give you things on the interval. Okay, another way to look at the graphs is if you're given a graph, you need to figure out the equation of the graph. So first thing you want to do is determine the period. Well, this looks like a cosine curve, the way that it's set up. And to find the period, I'm going to first have to figure out what those intervals are in terms of what we're counting by. So I know that I go from pi over 2 to pi over 4, and that covers 2 intervals. So I just take my subtraction to get that distance, which gives me pi over 4. But that's 2 intervals, so if I want half of that, I divide it by 2 and I get pi over 8. That's going to be my interval. So everything counts by pi over 8. So that means I start at pi over 8, and then if I take pi plus pi over 8, that's 9 pi over 8. So if I subtract those two values from those two peaks, I get 9 pi over 8 minus pi over 8 is 8 pi over 8, which is pi. So my period is pi, which is going to work out pretty nicely. Now what I need to do is I need to start figuring out the values, the pieces of my equation there. So what that looks like is I know my vertical shift is pretty easy, the amplitude is pretty easy. The b value is hard. The b value is not pi. The period is pi, and the period doesn't show up in my equation. What we need to look at is the period equals 2 pi, which is the standard period, over b. Well, to get to pi, b has to be 2. So the 2 is going to go in there. Well, I know that I have a phase shift to the right of pi over 8, which means I'm going to have to add pi over 8 to that equation. That moves it to the right. So I'm going to change that quickly to an addition. That's an easy mistake to make. So that's going to be plus pi over 8. And then I want to figure out my amplitude. So if I take my maximum point 1 to -3, that's a distance of 4. The sinusoidal axis will be halfway in between there, so down at -1. And so I plug that in for c, that's my vertical shift. The amplitude is half of the total distance between the max and the min, which in this case is going to be 2. I know it's a plus because I haven't inverted my cosine curve. So I know that I have a plus 2 there. That should be the equation of my graph. Now if I want to check it, as I should, I pick a point that I seem to know the value of, so a maximum or minimum is usually the easiest. I could also pick in where I'm on the sinusoidal axis, but if I plug in 9 pi over 8, I should get out a 1, and if I check that equation, it's going to work for me.